Welcome everyone. This video is a little bit awkwardly framed, and that's because the system that I'm testing out today is backwards, or upside down, or flipped, or however you want to call that. This is the all-white build that I did in the Lian Li 011 Evo. It is a system that I put together for my wife, and today I'm doing my follow-up video on it where I'm going to do some testing and answering some specific questions that I got asked a lot after I set the system up. I've narrowed it down to 3 things we're going to be testing today. The first is the mounting for the all-in-one liquid cooler. I used the LGA 1200 mount rather than the LGA 1700 mount. Is it going to work? Is it going to be fine? Second is going to be the RGB lighting configuration, and you can see I've done a little bit of work with that. I'm going to be showing you the software for that and testing out a few configurations. And third is going to be my decisions for the fan orientations in this build, because it is very positive pressure. In fact, all the fans are intakes except for this single one at the back, which is an exhaust. So I'm going to flip a few banks of fans around, try a few different configurations, and we'll find out if I was right, or if you guys are right, or if it just doesn't matter.
Excellent!
Today's video is brought to you by the new Lightwings fans from Be Quiet, which combine legendary near-silent operation with optimal performance and, of course, RGB lighting. Control the look of your PC with up to 20 addressable LEDs per fan, and choose from standard PWM for airflow or PWM high speed for use with radiators and heat sinks. They're available in 120mm and 140mm sizes and suitable for any build in need of a functional and tasteful RGB upgrade. So for more on the new Lightwings fans from Be Quiet, click the sponsor link in the video description. So first off, guys, I'm not doing a full setup walkthrough today, but I will post links in the description to a few tutorial videos that I have on that subject if you have just built a system for the first time. I'm going to be focusing on answering those specific questions that I talked about in the intro, but the first thing I want to do with any new build is just verify that everything is functioning in the way that I would like it to function. So for that, I popped up Hardware Info 64 here, and I did go into the motherboard's UEFI to update the motherboard to the latest version, of course, and also to plug in the memory XMP settings. So I'm running at 2800 megahertz. DDR, or double data rate, means that's running at 5600 speed, and that is the proper speed for my Corsair Dominator Platinum RGB kit that I have installed with cast latency 36, of course. The second thing is going to be for the CPU, the 12700K. Like I said, with the advent of the LGA 1700 socket, there is a new mounting configuration. The mounting holes are a little bit wider, a little bit more spaced out than with the previous LGA 1150, 1151, and LGA 1200, which all used the same design. A lot of the new ASUS motherboards, though, have mounting holes for both LGA 1200 and LGA 1700, and because the all-in-one cooler that I installed did not have the mounting kit yet for LGA 1700, I used the LGA 1200. Long story short, I'm going to run Cinebench multi-core right now, and we'll take a look at our temperatures as well as, I guess, our score as well to make sure that our 12700K is actually functioning properly. Right off the bat here, we can look at our core temperatures over in Hardware Info 64, and we can see we're peaking at around 70 degrees Celsius, 72 degrees, 73 degrees is the hottest we're getting. And the nice thing with Hardware Info is you can collapse that and it will just show you the maximum core temperature that you're hitting. And 75 is totally fine. If I ran this as an extended test, which I'm going to do in just a few minutes, we'll probably see temperatures get a little bit higher than that as things get a little bit more heat soaked inside, but our score was 21,361. We can also see our P cores over here getting up to 4.9 gigahertz, which is what they should be running at with these stock settings out of the box with only XMP plugged in. And a score of 21,300 is right in the same ballpark that we've been seeing for other 12700Ks, usually in the 21 to 22,000 range is what I pulled up for those. Next, we get to take a look at the RGB lighting and the software that I'm using to control that. And the Corsair software is called iCue, and I've used that quite a few different times before. And part of my goal for this build was to use Corsair components and ASUS components for the RGB, because ASUS and Corsair have worked together, so the ASUS components are recognized by the Corsair software. And if you've dabbled with RGB lighting in a computer system before, you might have encountered the problem where you have multiple things that light up, you need multiple pieces of software to control it, and it can get pretty bloated and also pretty confusing to try to sync everything up together. Unfortunately, because I'm using some pretty new hardware from ASUS, it's not officially recognized by the Corsair iCue software yet. So for instance, we have an ASUS GPU VGA1 right here, but it's not telling us that it's specifically the white version of the RTX 3090. We also have ASUS motherboard here, which is giving us some control over the lighting effects, but not complete control because it's not recognizing the specific model to control, for example, the individual RGB LED headers. So from what you can see in the system right now, this is just default, Everything is being controlled by the Corsair software except for the ASUS ROG all-in-one cooler and the RGB elements on that, as well as the LED strip on the front of the Lian Li 011 Evo case. That is plugged into the RGB header on the motherboard, but that is not currently being controlled by the Corsair iCue software. I can control that with the ASUS Aura Creator software, but I don't want to load that up quite yet until I've messed around with this one, because when you're running two different types of RGB software, both trying to control the same thing, it can be difficult instructing which set of software to control which component, like the graphics card, for example. But let's look at some lighting configurations, and again, everything is being controlled by Corsair iCue right now, except for the ASUS ROG all-in-one cooler, the lights that are on the CPU pump block, and the front strip on the case. However, those are both defaulted to white right now, so we can mess around with some of the other stuff. And for that, I've created a few scenes in the Corsair iCue software. The scenes are supposed to be sort of overarching themes that apply to everything in the system. So right now, it's defaulted to Corsair Watercolor, which is sort of a lighter variant of the RGB vomit that everyone either loves or hate. But I can just click white, for example, and everything turns white. Or I made this one that's pink. I can just click that. Everything turns pink, except for, of course, those two white elements that are still white. But I'm okay with that, because I feel like the white still matches with some of these other color schemes. But here again, just wanted to point out this software is controlling the RGB LEDs on the graphics card and on the motherboard, and that's kind of nice. Helps everything blend in a little bit more, especially with an RGB configuration like this. Now, I'm not a huge fan of like all of the default RGB configurations. Like this is supposed to be rain. I don't know. I don't like the rain. Do you guys know? Joe, what do you think of the rain?
There's like a seizure going on.
It's a little too frenetic, a little too scattered. We do have a visor option. This is the default visor option, and visor is kind of cool because it will run across all of the different components, and you can make sort of a theme that sort of chases around your system or something like that. But in order to do visor properly, you do need to have the LEDs properly configured so that it goes in the right order, for example. Is it going in the right order right now? Okay. And we have some more defaults like Corsair 1 blue or Corsair yellow, of course, or just static red. Or if I just turn that off, again, it goes back to the defaults. Beyond the defaults, you can set up your own profiles, and I've done a couple here just to demonstrate some examples of some things that I look cool. Like here is a blue and purple gradient. And note that if you don't want to use these scenes, which are supposed to be kind of simpler and quicker and more easy to use, you can get more detailed by going into each individual component, going to the lighting channel, and note that there's lighting channel and there's hardware lighting channel. Hardware lighting is for the device to remember even when the software is not controlling, so when the system is booting up for the first time or shutting down, you can tell it what behavior you want it to have. However, when you have booted the system up and it's being controlled by iCue, it will use whatever you set up for the lighting channel, and here you can add multiple layers. So I just did a gradient. I like this as an alternative to the RGB vomit because you can just select a few specific colors rather than having the entire rainbow spectrum, and if you have it start and end on the same color, then it will cycle and hopefully look pretty nice. Now when I put the system together, I tried to plug all of the RGB LED headers from each fan into the controllers in a specific order so that I wouldn't have to mess around too much with configuring that in the software. If you go to lighting setup, it will turn on just a single LED from each fan, one blue, one green, one yellow, one red. Or on this other controller that has 6 fans connected to it, it will turn each one a different color, so you can look here at the ports and then look at the fan directly and tell which fan is where, and then you can just drag and drop these to move them around and reconfigure them. So you can see by the numbers here, number 1, number 2, number 3, number 4, number 5, number 6, that I've reorganized these, and the reason I did that is if I go and put them back the way that they're supposed to be, and then I switch to my white plus visor, for example, here, it's not exactly going in the right direction. It's coming back the right direction here, but then it goes to the top, and then it goes down the side. So I was able to use that lighting configuration thing to determine that my setup needed to be like this. 1, 2, 3, and then 4, 5, 6. And then it should be going in the right order. You can see it goes across the bottom, up here, bounces through the components attached to the motherboard, then back down, back across the bottom, up the left side, and across the top. So this configuration for me is my favorite right now because I like it being all white. I think it's very bright, but it's also using the RGB elements just to do a little bit of an accent color with the visor going across everything. And because I'm only running the Corsair iCue software right now, and the two lights that it's not controlling have defaulted to white, I can just leave that as is and it will still go across the GPU and the motherboard. That said, I'm now going to break that functionality by loading up the ASUS Aura Creator software. And the ASUS Aura Creator software is actually pretty cool as well. It has some functionality that iCue definitely does not, but if you go over to your components, you can see a layout of them right here. The ASUS software is recognizing my RGB LED strips, the motherboard, the graphics card here, and the LEDs on the AIO. I also did a little bit of messing around with this just to try to get an all-white color and everything. So all you do here is select as many or as few of the RGB elements as you want, and then you set as layer to create a layer. By the way, you also have device as well as PC components, so if you had ASUS RGB devices connected as well, then they would show up here like a keyboard. But once you've created a layer, you actually have a timeline down here that goes as far as 6 minutes long, and then you can go ahead and add an element to that. So if I just wanted everything to be white, I would add the static white element there. That's controlled up here in the top right, and since this is a pretty basic one, we're just going to choose what color we want it to be, hit OK there, so now we're looking at white. And then the timeline is actually pretty cool. If you've ever done like a non-linear video editor or something like that, you could see how you can create multiple layers, choosing just specific elements of the RGB stuff that you have set up. You can make each one of those last as long or as short as you wanted to. I've just been stretching this to take up the full 6 minutes. And then if we hit save and apply, it should have turned all of these devices white, but my visor effect is now no longer going to go over the motherboard and the graphics card. It's just doing the memory because the motherboard and graphics card have now been taken over by Aura Creator, and that's fine for now. I did, like I said, do a gradient option here as well, and I do like the ASUS options for creating a gradient pattern. I just did sort of a pink to purple one here. So if we save and apply that, now we have a pink and purple gradient that's going over all of these ASUS controlled devices, and then I could go back to the Corsair software, switch to my blue-purple gradient for that, and now everything should match to some degree. But here's how you could possibly take multiple colors rather than just doing something that's static, combine the two softwares together and make them sort of play in harmony without it being too apparent that you're using two separate softwares to control it that aren't necessarily communicating with each other. So as a quick rundown of the RGB lighting control and a look at some of the configurations I've done for this setup. I do have some follow-ups to do with my wife. She has some specific requests for this build. She's talking about Hello Kitty stickers and stuff like that. I told her just let me do the video first, and then you can do whatever you want with it afterwards. But now that you guys have a better idea of how this works and how it can be configured, if you guys have any suggestions, I'd love to hear those in the comment section down below. And although this is my follow-up video on this build, I will be doing at least one more when we actually integrate this into our computer room and set it up where it's supposed to be. So I'll at least give you guys a quick look at it there. So if you guys have any more feedback or suggestions for lighting configurations, please let me know in the comment section down below. Next up, we need to run some stress tests to get a baseline of the temperatures we're seeing for the CPU and graphics card with our current fan configuration. I'll be right back with that. All right, guys, we have finished our TimeSpy stress test. So we're just using this TimeSpy stress test to validate. This is with the original configuration. It ran 20 loops, and we are checking our maximum core temperatures, which is 69 degrees Celsius, 70 on the package, and our max GPU temperature was 67.8 degrees Celsius. Now, I'm gonna flip some fans, see if anything changes. Okay, our top three fans have now been flipped, so they are now set to exhaust. These are the back of the fans up there, so air is coming up and out. The reason I had them set to intake is because this RTX 3090 has three fans on it too, and the way these fans turn on this 3090 and pretty much any graphics card is directing the air that way, down into the card and across all the heat pipes and fin stacks and everything, so it can keep the card cool. So in my mind, these fans pointing that way and these fans drawing this way would have been in conflict, so that's why they were drawing in before, to feed more air towards the graphics card. Now these are set to exhaust, which means we have a more balanced airflow set up now with 3 intake at the bottom, 3 intake here for the radiator. That's also the radiator for the AIO right there. 1 exhaust in the rear, bottom, back part, and 3 more exhausts across the top. Let's run that stress test one more time and see what happens. All right, loop 20 is now complete. Our results are popping up. 98.3%. So obviously our frame rate stability has dipped a little bit, so that's an indication right there that I was right. I was right with the original configuration. However, we should also double check our actual temperatures. Max CPU temperature, 67. That's a little bit cooler. Package. I'm sorry, max core temperature is 66. Meanwhile, our GPU temperature, oh, I didn't scroll, 72.5. And memory junction was 90. Oh, look at that. That's a significant difference. That's a significant difference indicating that I'm right. But we're gonna try one more configuration here before we give you guys the final results. And here we are at the end of loop 20 and round 3, and we get to see our results pop up here in just a second. 97.6. We've gone down even more, which is obviously, again, indicating that I am still very right about all these things. All right, so let's take a look at our temperatures. Core and package temperature maxed at 70 degrees, and our GPU, 72.9. Hotspot, 82.8. Memory junction, 88. Okay, and there are my results really quick, you guys. So on the top here is our original configuration, which was very positive pressure, and there the CPU got up to 69 degrees Celsius with 70C on the package. GPU temperature was 67.8 degrees Celsius with 77.8 on the hotspot and 84 degrees on the memory junction temperature. Switching the top 3 fans to exhaust and a more balanced setup resulted in a slight improvement in our CPU temperature. It dropped by about 3 degrees to 66C on the core and 67 on the package. However, we saw a 5-degree increase in our GPU temperature from 67.8 up to 72.5, 82.5 on the hotspot, and 90C on the memory, which is a decent amount warmer, and I would say not necessarily worth the trade-off for the slightly lower CPU temperature. Finally, with our negative pressure setup, our CPU got up to 70 degrees Celsius, the hottest we saw out of any of the configurations, 70C on the package, pretty close to our original test configuration, but just a little bit warmer. And then GPU temperatures were similar to that balanced setup, 72.9C, actually the hottest we saw on the GPU core, 82.8 on the hotspot, and 88 degrees Celsius for the memory. So the obvious follow-up from the people who were maybe a little bit hesitant about my original fan configuration for this build would be, well, what about that back single fan? We could flip that around and maybe that would make a huge difference. Or maybe some of the fans should be intake and some exhaust on the same setup. Okay, obviously that would be a little bit silly, but the point is there's lots of different fan configurations you can do in this case, and I haven't even tested stuff like if the GPU was moved over physically to the upright layout, or of course other fan configurations. But I think what I at least showed here was that my base instincts to have fan intakes pointing directly at the fan intakes for the GPU was the right call. And I think that is what I'm going to be flipping the fans back to for long-term use. But it was interesting to test out a few different configurations, and let me know what you guys thought about it in the feedback section down below. Leave me a comment. Let me know what you think of this build, the different lighting configurations that I did, and I'm not planning on doing further extensive testing with this system, but if you have anything in mind, might as well leave that in the comment section down below. I will be doing a follow-up video on my wife's setup, so I could possibly add a little bit more in there as well. Again, links to all the parts in this build are down in the video's description, and be sure to check out my original build video if you didn't watch that. Assembling this thing was a little bit more interesting and different than your typical PC build. Thank you guys so much for watching this video though. Hit the thumbs up button on your way out if you enjoyed it. Check out my store at paulshardware.net where you can buy shirts, mugs, pint glasses, hoodies, and all manner of high quality merchandise. And subscribe to my YouTube channel if you'd like to see more videos like this one in the future, including my weekly tech news series that goes live every Sunday. Thanks again guys, and we'll see you in the next video.